Okay, we're back to talk a little bit about limited reagent. Now, in the past or previous problem, we look at the moles. We said if this reaction of C2H2 and 2 hydrogen gas, 2 moles of hydrogen gas, remember we balanced it? We balanced the hydrogen last. We made 1 mole of 6. Then the problem says we have 6 moles of C2H2 and 6 moles of H2, but let's look at that individually. I took 6 moles of C2H2 first. Now, that 6 moles required, basically, is 6 times 1, required 12 moles of hydrogen. Remember, this ratio stays the same. So if this is 6 times that, this has to be 6 times that, which is 12. And 6 times 1 is 6. So if run this problem with 6 moles of C2H2, we need 12 moles of H2. Let's make 6 moles of C2H6. But do we have 12 moles of hydrogen? No. Remember, the problem says we only have 6 moles of H2. So that means H2 is the limited reagent. We don't have enough of it. We only have 6 moles. So then we have to go back and calculate basically what we require for 6 moles of H2. For 6 moles of H2, we only require 3 moles of C2H2. So you only require 3 moles of C2H2, and that makes 3 moles of the product, C2H6. So hence the 6 moles of H2 is the limited reagent. Now, what if we don't have anything in moles? And that's the next problem we're going to talk about in a second. Okay, let's look at the new problem, number 38. Here we have an unbalanced, not a balanced reaction. So propane react, so the propane react with oxygen gas to form CO2 and water. And it's not balanced. And then the problem, if you look at the problem, says that we only have grams, 10.02 grams of propane and 16.5 grams of CO2. I'm sorry, grams of oxygen. Now, then it's asking us how many moles, not grams, how many moles of CO2 are we going to make? Again, we have all grams, so we have to really convert the grams to moles. That's really, so the first thing is first, sorry, we have to balance the reaction. So we number of carbon and hydrogen. Then we, number 2, I wrote down, we set up the table. So the table is really helping us the ratio of moles. That's always the key at the beginning to set up the table to become comfortable. Number 3, I wrote down we need to measure the number of moles, and reminding the number of moles is always no formula. This number of moles is of the grams of the molar over molar weight. That's really good to remember that. So we always say number of moles. If you remember this formula, it's really going to help us. Gram of anything over molecular weight of that material. So we can convert that 10 grams of propane and 16.5 grams of oxygen to number of moles to use it. So we need to use that. Now, if you don't have the molecular weight, we can calculate that. We can calculate the molecular weight, or we can look up Google's or something to tell us what the molecular weight is. Either way, we need that number. We need that number. So once we have the number of moles of propane, then we use the ratio. I'm going to go over that in a second. We use the ratio, see which one is the limited reagent. Now, once we have the number of moles, again, number of moles, we see if we have enough of that material or not. and I'll go over that in a second. So we need to know that to be able to figure out which one is the limited reagent. So if we don't have enough of something, means that material is not a limited reagent, is not a limited reagent. Just look at, easiest thing is to look at so if you look at the same problem, a little bit smaller because the way I want to put everything on the same page. So again, we have a unbalanced reaction. Remember, we need to balance it. We have 3 carbons and 8 hydrogen and 2 oxygen on the left side, 1 carbon, 2 hydrogen and 3 oxygen on the right side. Now, if I put a coefficient or balance the reaction by taking the 3 carbons, do the carbon first. So we say we're making 3 CO2. And then we look at the hydrogen. We say we have 8 hydrogen here. So that means the number I have to put in front of the water is 4. So 4 times is 8. Now I have hydrogen and carbon balance. Now we look at the oxygen. Remember, oxygen we do last. It's by itself, lone one. So if I have 4 oxygen here and 6 hydrogen here, remember 3 is multiplied by 2. So now I have 6 hydrogen and 4 hydrogen, 10 hydrogen. 10 oxygen. 10 oxygen. So for 10 oxygen on the right side, we need 5 O2 on the left side. So it's balanced now. We have 3 carbon, 8 hydrogen, 10 oxygen on the left side, 3 carbon, 8 hydrogen, and 10 oxygen. I was talking carbon. Oxygen on the right side. So it's balanced. Now we look at the balance here, and those numbers are the moles. We have 1 mole of C2H3 with 5 moles of O2 to make 3 moles of CO2 and 4 moles of water. Now I don't have 1, 5, and 3. So where did I get this 0.227? So we look at the number of moles for the starting material, which is propane. They told us, or Dr. Klein told us, we have 10.02 grams of propane. So if I take 10.02 gram of propane divided by molecular of propane, which is 44.1, again I wrote it here, so I get 0.227 moles of propane. That's all we have. We have 0.227 moles of propane. Not 1 mole, not 10 moles, only 0.227. Then we look at the ratio of 0.227 to 1. So if I look at the ratio of 0.27 to 1, I don't know the number of moles of oxygen that I need. I don't have that, right? I don't have that. And that's what this ratio comes handy. So I said I don't have the number of moles of CO2 for 0.227. So I don't have that. But I know the ratio of the moles is to 5. And that 5 is over here. So again, the number of moles of O2 is becoming an algebraic equation. Is 5, remember 5, divided by 1 is 0.7. And this is the factors that use when we measure the number of products, etc., etc. I'll talk about that later. So the 5 is here, 1 is here, and this is the ratio. So now that tells me for 0.227 moles of propane, I need 1.35 moles of oxygen. Again, for 0.227 moles of propane, I need 1.35 moles of oxygen. So let's see, do we have this number of moles of oxygen or not? We go back to the problem. Oh, at the same time, I forgot, if I have 1.35 moles of oxygen and 0.227 moles of propane, how much CO2 am I going to make? That's what I did next. So I said 0.227 again to 1. 0.227 to 1 is the number of moles of CO2, which I don't have, over 3. That's the 3 here, right? Ratio. So that moles of CO2 would be now 3 over 1 times 0.227, which gives me 0.681 moles of CO2. So this is base. This number of moles is based on 0.227 moles of C3H3. So let's go look at the oxygen. So the oxygen is a little bit different. For oxygen, the problem tells us we only have 6.5 grams. So that means for 6.5 grams of oxygen divided by 32, which is molecular weight, we have 0.516 moles of oxygen. And that's what this number is here. So we have oxygen now. So I put that in a table. So based on that 1.516 moles of the oxygen, we need to know how many moles of C2 propane we have, and how much we need and how much CO2 are we going to make. Again, ratio, guys. So 0.156 now for the oxygen over 5. Remember that 5 doesn't change. 0.55 over 5. Number of moles of CO2 we're going to make over 3. So number of moles of CO2 that we're going to make is 3 over 5. 3 over 5 times 0.156, 0.39 moles of CO2. So let's go back, do our little calculation here. For 0.227 moles of propane, we require 1.35 moles of oxygen. Do we have that? No. The problem says we only have, based on the calculation, we only have 0.15 moles of oxygen. So we really have not here. So what do you mean? That means the 0.56 or 0.152, if you use Sigfer, is really the limited reagent. So based on that limited reagent, we can only make 0.309 moles of the carbon dioxide, not 0.68 mole. We only really make 0.309 moles. So oxygen is really the limited reagent. Oxygen is limited reagent, and based on that number, we can make only 0.309 moles of carbon dioxide, and use 0.103 moles of propane. So we have leftover propane. We didn't use all the 0.27 moles. We only used 0.103. So we have excess propane. Hope you understood this limited reagent, and based on the limited reagent, how much product are we going to make? So limited reagent helping us to figure out how much product we're going to make. Thank you.